On April 13, 1970, Apollo 13 was roughly 200,000 miles from Earth when oxygen tank number 2 exploded. The remaining oxygen began venting into space, but oxygen also fed the fuel cells that produced electricity and water. Losing oxygen meant losing all three. The explosion was only the first problem. The lunar landing was over immediately. The new mission was to keep Jim Lovell, Jack Swigert, and Fred Hayes alive long enough to reach Earth in a spacecraft whose main life support system was failing. Apollo 13 survived because the crew and controllers treated the accident as a chain. Every solution had to protect the next resource: oxygen, power, water, navigation, breathable air, and finally the ability to re-enter Earth's atmosphere. The command module Odyssey could not remain fully powered. Its batteries were reserved for the final hours before re-entry, when no other spacecraft could bring the crew through the atmosphere. The crew moved into the lunar module Aquarius. It had its own oxygen, batteries, computer, and descent engine. Hardware intended to land 2 astronauts on the moon now had to shelter 3 astronauts on the journey home. Aquarius was designed for about 45 hours of normal operation. The emergency demanded roughly twice that lifetime. Controllers shut down non-essential equipment and reduced electrical consumption to about 1/5 of the normal level. That power down preserved the batteries, but it removed heat. The cabin temperature eventually fell to about 38 degrees Fahrenheit. Moisture condensed on walls, panels, and wiring while the crew tried to sleep in a cold, crowded vehicle. The lifeboat solved the immediate oxygen problem. It did not solve the route home, the limited water supply, the rising carbon dioxide, or the need to wake Odyssey after days in the cold. Before the accident, Apollo 13 had left a free return trajectory so it could approach its planned lunar landing site. The crew could not simply drift and expect to reach the correct corridor at Earth. About 5 hours after the explosion, the lunar module's descent engine fired for 35 seconds to restore a free return path. After Apollo 13 passed behind the moon, a second, much longer burn shortened the voyage home. Navigation was unusually difficult. Debris from the damaged service module surrounded the spacecraft and made real stars hard to identify through the optical system. Controllers developed an alternate check using the sun. When the sun appeared where the calculations predicted, the guidance alignment was within half a degree. That gave the crew confidence to perform the return burn with the lunar module, an engine and guidance combination never intended for this exact job. The moon was no longer a destination. Its gravity became part of the rescue route, bending Apollo 13 around the far side and back toward Earth. Power was counted in ampere hours. Water was counted in ounces. Every device left on produced heat but consumed electricity. Every system shut down preserved power but made the cabin colder and the restart harder. The crew reduced drinking water to about 6 ounces per person per day, roughly 1/5 of normal consumption. They became dehydrated, but the lunar module finished the emergency with water still aboard. Controllers also devised a procedure to move electrical energy from Aquarius into Odyssey's batteries. The direction of power flow had to be reversed, so the command module would have enough energy for re-entry. This was not a single heroic calculation. Teams on the ground wrote procedures, tested them in simulators, checked them against changing spacecraft telemetry, and then read the steps to the crew. Each margin remained connected to the others. A faster return saved water and power, but required accurate navigation. Preserving batteries meant accepting cold. Keeping 3 people inside Aquarius created a new air problem. The lunar module removed carbon dioxide with round lithium hydroxide cartridges. The command module carried more cartridges, but they were square and would not fit the lunar module's round openings. After about a day and a half in Aquarius, The carbon dioxide level approached a dangerous limit. The spacecraft had enough filtering material, but not the correct connection. Engineers on the ground built an adapter from materials already aboard: plastic bags, cardboard, a hose, and tape. The crew followed the transmitted instructions and forced cabin air through the square cartridges. The device became known as the mailbox. It did not repair the spacecraft. It removed one immediate threat without consuming the power and water needed for the next stages of the return. Odyssey had been nearly dormant for 4 days. Normal activation procedures took months to develop. Controllers assembled a new power-up sequence in roughly 3 days, stripping it to the minimum required for re-entry. Condensation made the restart more frightening. Water droplets covered surfaces and may have collected behind panels, but safeguards added after the Apollo 1 fire helped prevent electrical arcing. Before re-entry, the crew jettisoned the service module. For the first time, they could see the physical damage. An entire exterior panel was missing, with wreckage exposed around the oxygen tank bay. Aquarius was released next. The vehicle that had served as a lifeboat for 4 days was no longer needed once all 3 astronauts were sealed inside Odyssey. On April 17, after 5 days, 22 hours, and nearly 55 minutes in flight, Apollo 13 splashed down safely in the Pacific Ocean. The investigation traced the accident back before launch. Oxygen tank number 2 had been dropped during earlier handling and later proved difficult to empty during a launch pad test. Technicians used the tank's internal heaters for about 8 hours, powered by 65-volt ground equipment. Thermostatic switches in the heater circuit were rated for the spacecraft's 28 volts and likely welded shut. The temperature gauge stopped at 85 degrees, so it could not reveal that internal temperatures may have reached roughly 1,000 degrees Fahrenheit, damaging Teflon insulation around wiring. In flight, Mission Control requested a routine stirring of the cryogenic tanks. Damaged wiring likely short-circuited, starting combustion inside oxygen tank number 2. The pressure vessel failed, a service module panel blew away, and the second oxygen system was damaged. The review board called the accident an unusual combination of mistakes joined to a deficient and unforgiving design. Apollo 13 returned because the response was the opposite: redundant teams, conservative margins, tested procedures, and solutions that anticipated the next failure. The explosion began the crisis. Survival came from understanding the chain it created. Next, the archive examines Chernobyl bull and the radiation reading that could not show how dangerous the reactor had become.